Hello everyone, now in this video we'll be talking about Cambridge's approach. Now this approach is called so because it was basically derived by different economists studying in Cambridge University. Now it basically says MD is equal to KPY. In case you're asked what is Cambridge approach, you have to write MD 1 by K is equal to PY. Just basically dividing it over here. But now we'll understand what exactly this is. So again, starting from the left hand side, we have MD, which is money demanded. K is the new term over here. If you remember from this particular formula, which was MVPY, MD is money demanded, which was also here. Now K is a alien concept over here, but let's keep it for later. P is again the price level and Y is income. So now let's talk about K. K is basically the money kept aside. In case you remember, in this Fisher's approach, we assume that no money or no part of our income is saved, right? But in this approach, which was more practical and pretty much real, Cambridge's economists also emphasized the fact that people keep aside some part of their income for future use. So this part was K. So money demanded is the money kept aside, multiplied by price level, which means the price prevailing in the particular economy at that time, and Y being the income. So yes, this was our Cambridge approach. Now let's talk about K and V, which are the two differing terms in this approach. Also, before starting that, I would like to mention the assumptions that we have to take while talking about Cambridge's approach. So the first assumption is some part of the income is kept aside in form of K, and second is that money is used as store of value because it was also stored, right, in form of K. If you remember that in Fisher's approach we assume that no part of the money is saved or income is saved, and it is used as a medium of exchange because we didn't store any value. But here we clearly have this value which is store of value. So yes, these are the two assumptions again in Cambridge approach. Now let's talk about relation between K and V. As you remember, V was velocity and K is kept aside, right? So if you pay much attention to it, then if you suppose this is, for example, your locker, and you just decided that you're going to save this 100 rupees from your income of say 1000 rupees. This was your income, which is Y, and you decided to keep this K part aside. So now, since you have kept it in locker, there's no possibility of using this money in order to make payments. Now, making payments was velocity, in case you remember, right? So if you store some money, then definitely the velocity is going to decline because now you won't be able to make payments using that particular money. So we have a result which is K is inversely related to velocity, or we denote it as V is equal to 1 by K, same thing. So this is the result that we use here. Now we have these, let's keep these both approaches side by side in order to understand how it's affecting or how the results are being basically converging into the same thing. So we have Fisher's approach and we have Cambridge approach. Since we know that K is equal to, even though this is correct, but what we have to use in our formula is V is equal to 1 by K. So Fisher's approach gave us MV is equal to PY. Whereas what Cambridge approach gave us was MD is equal to KPY. Now keeping this same, let's keep it same because it is in the most simplified form. But now what we can do is MD is equal to 1 by K is equal to PY. Okay, since we are talking about equilibrium, everything is at equilibrium, we have to assume that as well. So MD is equal to MS, and let's assume it to be M. So you can also replace this MD with simply M in order to reduce your confusions that is arising. Also now you have M into 1 by K is equal to PY. What we did is just to divide K with M. Now using the value over here, we can substitute 1 by K with V and PY. So yes, we can see the results are same, isn't it? So that is why I mentioned the fact that both approaches give us same results, but using different ways. For example, in Fisher's approach, we didn't even think of saving any part. Saving was not allowed here, but we saved a part of money over here, which is far more practical. But eventually the result that we got was same. So yes, this is pretty much about it. Thank you.